Good morning, good afternoon, good evening, whenever you're listening to this. I hope you're doing great. About to dig into the PARCC test, which I know a lot of you have already told me, and this is pretty tough, but I want to encourage you and just say, hey, you know what? You guys are the best and the brightest, and you guys are going to do great. It's just a matter of familiarizing yourself with this test and making sure that you know as much as you possibly can know. And like my high school math teacher always used to tell me, he used to tell all of us, he'd say, you know, you don't have to get every single problem right. You just have to get the ones that you know how to do right. And so that's my goal in introducing and showing you this PARCC test, to show you the format. And then from there, you know what? You're going to do great, okay? And so I'm excited for you guys to take this test. A lot of good questions. A couple things I want to show you before we get started here. First thing is this. If you type into your search bar or even into Google practice PARCC test like I've done up here, and this first site that comes up here, parcc.pearson.com with the practice test, I'm going to go ahead and click on that, and you'll see two options here. You got English Language Arts and Literacy practice test, and then you've got the Mathematics practice test. I'm going to click on that, and then you've got your answer keys, and I'm going to click on that, okay? And then from there, and then obviously I'm videotaping this, so you can go back and look over this. But what we're going to do today is the paper performance-based PBA, performance-based, I can't remember what the A stands for. Anyways, practice test answer keys. Maybe it's, anyways. And I'm going to go down here to geometry, and I'm going to click on that. And there's something that caught my eye on the very first page that I wanted to bring to your attention. You may want to go ahead and read over this page. Take a moment to do that, but this very last thing, unless otherwise stated, students must define variables when using them in a model. Students that do not define their variables may not be able to earn the top score point. And so I just want to encourage you guys, as you guys are working through these problems to define your variables, make sure that the grader knows what you are referring to when you say X is this. Otherwise, they may not give you the highest point value. So, again, I want to go through all of this. Also wanted to show you this, where we were just at as far as the answer key. If you don't want to listen to me, you can actually scroll down through here and see a lot of the information that I'm going to go over. I may do it in a little bit different way. I may kind of step through why some of the problems should be what they are and some of the problems aren't. And so I'm going to do that as I walk through this. I may refer back to this document here as I go along as well. Hopefully it's all understandable to you. If it's not, please come and see me and we can talk through any part of it. So this first problem right here, this is one of those ones I would expect us to get. It says this: the diagram represents a portion of a small city. Maple Street and Pine Street run exactly east and west. So these two running east and west of each other. Oak Avenue runs exactly north and south. All right, so the first thought that should be going through your mind right now is the fact that if this one runs north and south and these two run east and west, that these are going to be perpendicular to each other. I'm going to start with that before we even do anything else. And all the streets remain straight. Okay. Which statement must be true based only on the given information? Select all that apply. That's the hard part. Select all that apply. When you think you got the answer, there may be another one in there as well. So the first one is Birch Street and Elm Street intersect at right angles. Let's see here. They look like right angles. Yes. Okay. But there was nothing up here that was shown to us that is telling us that, or we could lead us to a conclusion that we have right angles. So as a result, we're going to cross that one off. We do not know that one for sure. Letter B says Maple Street and Pine Street are parallel. Well, if these streets both run exactly east and west, they're not on top of each other, which they're not, they must be parallel to each other. So I'm going to check that one. That one is one that you would want to answer in your answer document. Letter C, if more of the map is shown, Elm Street and Oak Avenue will not intersect. Elm Street and Oak Avenue. Well, the key here for this one, all of the streets remain straight, meaning this one continues on through, and this one right here. So as a result, instead of they will not intersect, they will intersect. And so this one is not going to be an option, okay? Those two streets will eventually intersect. Letter D, Pine Street intersects both Birch Street and Elm Street. Pine Street intersects both Birch Street, right there, and Elm Street, right there. So we are good with that. One of your answers. And then the last one, Oak Avenue and Maple Street are perpendicular. Okay, well, we already said that. If one goes directly north and south, one goes directly east and west, we have a perpendicular angle there. So those are the three answers that you want to put down there, B, D, and E. Okay? All right, the next one, let's see if I can scroll down here. In the coordinate plane shown, point C, not shown, lies on AB. Okay? If the ratio of the length of AC to the length of CB is 3 to 1, what's the y coordinate of point C? Okay? Now, if I were you, this is one of those ones that I would probably go ahead and graph out on a sheet of paper just to make sure that I had done everything correctly. But here's what I want you to see from this. If I go ahead and do the rise and the run, the slope between these two, I'm going from 2 to 10, which means that this length right here is a length of 8. Okay? Now I'm telling you right now, I'm petitioning for our administration to give all of you guys graph paper, and this would be a great one to use for graph paper. You can actually count out those vertical segments 8 units up. There should be no reason we can't actually put that on graph paper. And then the horizontal distance is going from 4 to 10, so this is going over 6 units. Now, if we are going to break this segment up into one part that's 3 and one part that's 1, together there are 4 parts up there, okay? And so as a result, I am actually going to divide each length by 4 and then multiply it by the corresponding lengths here, 3 and 1. So what I mean by that is this. If I have a vertical length of 8 and divide that by 4, that gives me 2. And then I'm going to multiply that by 3 right there to give me 6 units in the vertical direction. So if I go up 6 units from 2, I'm going to be up in there, and that's going to be at the length of 8. So 2 plus 6 gives me 8. So this is going to be 8 right here. Okay? And if I divide 6 by 4, that gives me, let's see here, 1.5. And I can multiply that by 1, but I don't really have to because it's already 1.5. Okay? And so as a result, okay, well, I got into the part of that last problem and realized I was heading in a direction I didn't quite want to go. And so I took a look at my notes and I was like, that makes it a lot easier to explain it that way. So I started to say that there are 4 sections up here, which is correct. And then from there, 3 of them is where we want to head from this point. So we're going to be up in here somewhere, okay? So how do we find both the x and y coordinates? Well, if we're going to go up 3 of the 4 portions, there are 3 in here with 1 right here, then we know that we're going to take that vertical and that horizontal distance and we're going to multiply each of them by 3/4. Okay? That'll break up that segment into the 4 portions that we need, and 3/4 up the way is where we're going to lie. Now the 3 is coming from the 3 right here. Okay? So as a result, 3/4 of 8 is going to be 6. And we already talked about that, how if we go up 6 from there, you're at the 8. And 3/4 of 6 is going to be 1.5, 4.5. Okay? So we are going to go over 4.5 units. Now, if I go over 4.5 units from here, if I was to make a little note here, 4.5, that means that this ordered pair, okay, you notice here you were already at 2. So there's 2 here, and we're going to go over 4.5. So the ordered pair is actually going to be up 8 and over 6.5. Okay? Now again, where did I get the 6.5? Well, there are 2 units right here, and then there were 4.5 units right there, and then from there it's that point right there. So this all could change. If it wanted to be like 4 to 1, you would just go ahead and do 4/5. If you wanted it 2 to 3, it would be 2/5. Okay, so I hope you understand how we get that. If I was to change this problem at all, let me just go ahead and do that real quickly. If this was no longer 3 to 1, let's say it was 2 to 3, then you would take the vertical distance and multiply it by 2/5, and I'm getting the 5 from the sum of the two. Okay, and if you have the horizontal distance of 6, you would multiply it by 2/5 as well. And so the reason I'm doing it from 2 as opposed to 3/5 is because the lower point, that's where it's coming from, where we're breaking that section off from that lower point. So I hope that made sense. Go ahead and double check with me if you have any questions on that. And I guess I should have read my notes before I started explaining the next problem, so I'm going to do that real quickly. Okay, for this problem right here, we have a dilation problem, and we haven't really worked a whole lot on dilations, but I know you've watched a couple of videos on them. And it says this: in the coordinate plane, the line P has a slope of 8 and a y-intercept of 0,5. So what I tried to do right here, went up to 0,5, did a slope of 8. We've got our line that they're referring to right there. Line R is the result of dilating line P by a factor of 3. So line R is going to have to be 3 times as large as line P. Okay? With a center at 0,3, what is the slope and what is the y-intercept? So 0,3 is here. Now why is that important to know? It's because if the distance from the center to this initial point is 2, and the factor of dilation for line R is 3 times as much, we're going to take that distance of 2 and multiply it by 3. So I get 2, 4, count again, 2, 4, 6, right there. Sorry about that. I don't know if you heard my phone go off there, but yeah, I apologize about that. Anyways, as I was saying, the dilation has a center of 0,3, and so if this line, if I'm going to multiply it 3 times, it's going to be larger, the other line's going to be 3 times as large, then I have to know the distance from the center to the point of dilation. So it's length of 2. So if I go 2, 4, 6, this is my starting point for the next line. Now from there, every single dimension from this line right here is increased by a scale factor of 3. So, excuse me. So as a result, if we're going up 8 and over 1, from this point, I'm going to go up 3 times 8 and over 3 times 1. So if I do that, this is going to go up 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, so there's 24. Okay, and over 3 times 1, which is over 1, 2, 3. Okay? Now what I want you to see from all this is that the slope of these 2 lines is going to be the exact same. Okay? Because each dimension is increased by the same amount. Okay? And so as we look through these, does line R has a slope of 5, which would be incorrect because it has to have the same slope as the previous one. So I'm going to go ahead and get rid of that one and get rid of this one because it can't have a slope of 11. Dilations have the same slope because they're increased by the same scale factor. Line R has a slope of 5 with the y-intercept at 0,5. Well, if we look here, the y-intercept here isn't at 0,5 because that's down here. So this one is gone. Okay. Line R has a slope of 8, which it does, and a y-intercept of 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There you go. This is our answer right there. Here's what I want you to know from this problem. Dilating anything is going to increase it by a scale factor, the dimensions. So if you're dilating line segments, you're going to create other parallel line segments. I think that's the key out of this problem that I want to make sure you guys understand for your test. So keep that in mind. Okay, number 4, the next one, we have two right triangles that are similar. And so remember what we talked about with similar triangles. We know that the side lengths are proportional, and so this side will correspond with this one, this side will correspond with this one, obviously the hypotenuses correspond, and that all the corresponding angles are congruent. So these angles are congruent, these angles are congruent, and obviously the right angles are going to be congruent. Now the hard part about this one is how do you draw the picture? You know, you really don't have anything to base your information off of. They expect you to come up with the picture on your own. And so what I would start out with is this. Let's see here. The similarity statement, we know that WXY is similar to the triangle DEF. And so make sure you're matching up D with W, E with X, and Y with F. Okay, that's the first thing. So have I done that down here? D with W, F with Y, E with X. Good, okay? Now you start plugging in your information. You know that F is 90, so you plug in 90, so you know Y is 90. You know that angle, or DF, is going to be 7, so I plug that in. I know that EF is going to be 8, and that DE is going to be 113. Now, and then you just match up everything else correspondingly. So I don't know how to make that any easier for you other than start drawing out the picture and start with the information that you know. The key to this problem is making sure that you have the similarity statement and you can match up those parts correspondingly. Now, how do we go from here? I will tell you this, we're going to hit trig functions pretty hard at the end of this week, so hopefully that will make sense to you after we get done with that. But we want to figure out what this angle measurement is right here, which, if you read your similarity statement correctly up here, it's the same as this one down here. So the cosine of W is going to have the same ratio of side lengths that the cosine of angle D will have. And so if I was to go down here, I'm first going to look at everything from the perspective of angle D. This side is the opposite side, this side is the adjacent side, and this side is your hypotenuse of the triangle. And so cosine, so ka toa, cosine is adjacent over hypotenuse. So if I set this up, the cosine of angle D is going to equal the adjacent side, which is 7, over the hypotenuse, which is radical 113. And, well, I can replace angle W with angle D because we know in similar triangles the angles are going to be the same. And so as a result, the answer to this one is going to be letter A. Okay? Okay, number 5 says this. The triangle KLM is the preimage of triangle K prime, L prime, M prime before a translation or transformation. Determine if these two figures are similar. Which statements are true? Select all that apply. Looking at the two figures, the slopes of these lines you can tell are parallel. Okay, you can tell that this one is parallel to this one. The slope of this one is parallel to this one. And so all the angles would have to be the same in order for the lines to be parallel. So you know that these angle measurements, being the same, make the triangle similar. So for letter A, I'm just going to go ahead and say yes, I know they're similar because the slopes of the lines are the same, the lines are parallel to each other, so as a result they would have to be similar to each other. So letter A is definitely an answer. Therefore letter B cannot be an answer. Okay. Letter C, D, and E, those are all grouped together. It says if they're similar, it has to be a dilation of what scale factor and where is it centered? Well, they're all centered at the origin, so that makes it easy. If it wasn't centered at the origin, you would want to go ahead and figure out where they're centered. How you figure out where it's centered is you want to take some sort of a straight edge, and you would want to go ahead and connect the points that are given. If I could do that here. Connect the points that are given. Okay, and then draw a line with that. Okay, and if I do that with these, okay, obviously with these big knobby points that I have, it's kind of hard to tell where exactly the center of those are going to be. But what I'm hoping that you're going to see here by me doing this is that where all three of these lines come together, okay, is right here at the origin. I know it doesn't look directly on the origin, but like I said, if I could be more accurate, those big knobs are kind of hard to figure out where the centers are. They want you to see that they all come together right here at the origin. That's how you figure out the center of a dilation within the figure there. Now the next thing is this. What's the scale factor going to be? Well, I know that C cannot be an answer because I know that this figure here is bigger than this figure here. And we are going from, let's see here. We're going from the smaller figure to the bigger figure, okay? So as a result, I know that C and D cannot be the answer. C, having a scale factor of 0.5 would mean the second figure has to be smaller. D, having the scale factor of 1 would mean that the figures are congruent to each other. Well, that obviously isn't the truth. And so the last one, it's going to be 1.5 times larger, is the one that you'd want to select. Now, how would you determine that? Well, I think the easiest way would probably be able to find the length of two of the sides that you could determine the lengths of. So what you could do here is this. If you go ahead and figure out the right triangle right there, okay, notice that each one of these is 2, so this would be 2, and this would be 2, 4, 6, and that would be 7, okay, 2 and then 7. And then this one, okay, is going to be over 2 plus 1, that would be 3. And then this would be 2, 4, 6, 8, 10. And let's see here. It's not quite 11 because 11's down here, right in the middle of the two. This is actually 10.5, okay? And so as a result, you notice that if we take 2 times 1.5, we get 3, and 7 times 1.5, we get 10.5. That's one way of determining it. They make it hard in the drawing because those points aren't directly on the corner of a grid, and that's why you have to kind of try and figure that part out. But yeah, letter E is the answer to that one. And then, is it a translation? Remember, a translation, if you guys have done these in the past, are just slides, okay? When you slide a figure from one part of the graph to another part of the graph, the two figures have to be the exact same shape. And so F and G are not possibilities. So again, the answer to number 5, answers to number 5 are going to be A and E. Okay, this next one. The degree measure of an angle in a right triangle is x. The sine of x is 1 over 3. So what I did was I went ahead and made up a right triangle. I know that this is going to be x. And remember, sine is opposite over hypotenuse. So when I went ahead and did this, what they're saying is that the sine of x is equal to 1 over 3. This side is the opposite side length. This is the hypotenuse side length. So I made the opposite 1 and the hypotenuse 3. Okay? Now as a result, they want to know what the cosine of x will have to be, or how to find the cosine of x. And so the big thing for this one is going to be this. Which of these expressions is equal to 1/3 using the cosine? Now cosine is the adjacent over hypotenuse. So if I were to do the cosine of x, 1's going to have to be the adjacent side, and 3 is going to have to be the hypotenuse side. Now the only way that I can reach 1 to be the adjacent side is if I move this angle from right here to being over in there. Okay? Now how do I do that? Well, remember, the sum of the three angles of a triangle add up to 180. If this angle is 90, that means that these two angles added together will equal 90. So if I go ahead and make, I know that this one's 90. If I say the cosine of 90 minus x, whatever x is, let's say it's 22, okay? If I take 90 minus 22, that puts me right here. That's the measurement of this angle. And so if I take the cosine of 90 minus x, that's going to give me 1 over 3 because now 1 is the adjacent side, 3 is the hypotenuse. So in looking at the answers here, letter E is going to be your answer for that one right there. In this figure, triangle GHJ is similar to triangle PQR. Now, make sure you're identifying which parts of those two triangles correspond to each other. So, GH corresponds with PQ. Let's see here, HJ corresponds with QR. And then we know PR is similar to GJ. Based on the information, which ratio best represents the tangent of H? Now, this angle at H is the same angle that we have at angle Q. Now, this is the second problem that we've had like this. Actually, the third if you consider the previous one as well. So if I go to angle Q, I know the tangent of angle H, which is the same as angle Q, is going to be opposite over adjacent. And so if I do this, the tangent of the angle, the opposite side, I would label all three of these before I even get going here. Here's the hypotenuse, which is opposite the right angle. Here's your opposite side, and here's your adjacent side. So if I do 8 over 15, opposite over adjacent, that's where I want to start with, and letter A is your correct answer for that problem. Okay? And it all comes back to that the corresponding angles within similar triangles are going to be congruent to each other. Okay, now, I believe that everything that we just covered is the non-calculator portion of the performance-based assessment test. Okay? So as a result, on the 24th, February 24th, that's Tuesday, I believe, all that will have to be covered. Okay? I don't think that'll be too hard for you. I think that most of that is just pretty straightforward, and you can figure it out on your own as long as you know the definitions of dilations and similar triangles and so forth. For this next one, this is the calculator portion of the test, and you're going to want to make sure that you've got all your calculators set up correctly. For example, when you're doing any of your trig within geometry, you have to have the mode in degrees. If you don't have it in degrees, then you're not going to be able to do it correctly. And so as I work through these, again, they're much more elaborate than the previous section, but I think I'm going to try to make it as understandable as possible. It says here, the figure shows the design of a shed that will be built. Use the figure to answer all parts of the tasks. The base of the shed will be a square measuring 18 by 18. Okay, so we have that here, boom and boom. Okay. The height of the rectangular sides will be 9 feet, and we can see that here. Rectangular will be a key we're going to come into a little bit later. And the measure of the angle made by the roof with the side of the shed can vary and is labeled as X. Different roof angles create different surface areas for the roof. The surface area of the roof will determine the number of roofing shingles needed in the constructing the shed. To meet drainage requirements, the roof must be at least 117 degrees. I would encourage you, knowing what's going to come up next, to make sure that you highlight any important information within the, let's see here, shed may vary and is X. Okay, just keep that stuff in mind because they come back to it, and if you don't remember it, you're going to miss that easy stuff later on. Now, the other thing I don't like about this is that they only give you one picture. And so if you have to tear this sheet of paper out of your test booklet and continue to refer back to the picture, do it. You know, there's nothing that says you can't tear a sheet of paper out of your test booklet and then put it back in. But you need to be able to see things. So I'm going to read part A. Again, it doesn't have the picture there for you. And so we're just going to do all of it on this sheet of paper here. It says, the builder of the shed is considering using an angle that measures 125 degrees. Determine the surface area of the roof if the 125 degree angle is used. Explain your process, enter your answer, and your work or explanation in the space provided. All right, now I'm going to go back to the fact that we have a rectangular sides. What that means here is we're going to cut this off, and that means that this is a 90-degree angle. Okay. Now the reason why that's important is because if I'm using 125 degrees, so this angle X is 125, I'm going to take 125 from 90 and I'm going to get 35 degrees. The 35-degree angle right there. Okay. Now we need to figure out. Let's see here. Determine the surface area of the roof. So we need to figure out the area of this rectangle right here, and then we're going to double it because there's another rectangle on the other side for the other part of the roof. So this is 18 feet right there. Now, in order to do that, I'm going to split that front there in half, making that a 90-degree angle. And we know that this length is 18, so this length right here is going to be 9 feet. Okay, so if I was to redraw that triangle there, here's what I have. And I would definitely put this down in my answer document to make sure that I have everything that my person that's grading it is going to want to know. Okay, so we're going to determine that length and then multiply it by 18 and then double it to get the total length of the entire roof line. So in doing that, let's see here. This is your adjacent side. This is your hypotenuse. Okay, and I would even write out my trig functions. So ka and then toa. Sorry about the ka. There, it's AH. All right, and as we look, adjacent and hypotenuse is what we have, so we're going to use cosine. So I'm going to set up the cosine of the angle is equal to the adjacent over the hypotenuse. Okay. Now, again, we're going to hit this pretty hard by the end of the week, and I know you're going to know this by then, but this is how you're going to go ahead and solve for x. I'm going to put this over 1, and I'm going to cross multiply. 1 times 9 is 9. X times the cosine of 35 gives us that right there. Okay? And then in order to solve for x, we're going to divide through by the cosine of 35. Okay, so x, that's going to cancel out, is going to be 9 divided by the cosine of 35. Okay? Now, I don't really need to know what that is, because in order to find the total surface area for this, we are going to take surface area of the roof is going to be this, 2 times the base, which would be 18, times the height, which is going to be 9 over the cosine of 35. Okay? And if you plug that into your calculator correctly, you're going to get approximately 395.5 square footage, okay, for the shingles of that shed. Okay, if you didn't get that answer when you plugged in your calculator, I would make sure that, you know, maybe you put parentheses around there just to make sure that you've got everything grouped together. If you still don't get it, come and see me, and we can talk through what you need to do to get that right answer. Now moving on to part B, it says this: without changing the measurements of the base of the shed, the builder is also considering using a roof angle that will create a roof surface area that is 10% less than the area obtained in part A. All right, so we're going to have to take this surface area and figure out what 90% of that, if it's 10% less. Less surface area will require less roofing shingles. Will such an angle meet the specified drainage requirements? Now that's the key. If you're looking at your paper there and you're reading through part B with me, I would underline that. Will such an angle meet the specified drainage requirements? Because as I was answering this, I forgot to look back at that. I answered the problem, but then forgot to answer the final answer. Explain how you came to your conclusion. And in your explanation in the space provided. So here's what I'm going to do. I know that the total surface area is 395.5 square feet. And so 10% of that, 10% less, is going to be 90% of it. So if I take 90%, 0.9 or 0.90, either way, that's 90%, okay, and multiply that by 395.5, that's going to give me 335.95 square feet, okay? So that's what we're aiming for. Now, on my paper, what I did was I drew both this rectangle here and the other rectangle. So I went ahead and did this. And I'm not saying that this is the only way to do this problem. I'm one that likes to use algebra, okay? But I have to figure out, and maybe I shouldn't label it as x because this is already x. Let's change that actually. let's label this as y and y. Okay, these lengths right here are going to be y and y. And so if I can figure out this length, I can actually go ahead and then figure out what this degree is going to be, which will then help me determine if it meets the drainage requirements. And so I know this length is 18, this length right here, 18. And so as I set this up, here's what I did. I said, okay, if the area of this whole roof is going to be y plus y, which is 2y, and I'm going to multiply that by 18, that has to equal the 335.95 square feet. Okay? And so from there, I went ahead and divided both sides by 18. Actually, you know what I did? I multiplied the 2 and the 18 together. Gives you 36y. And then I divided by 36, and I got y to be a length of 9.9 feet. Okay? The length of y was 9.9 feet. Now, the question still is, does it meet the drainage requirements? And here's what I'm going to do. I have to find out what this angle measurement is right there. And so in order to do that, here's what I have. 9.9. I have a length of 9 there, and I'm going to label this WXY. I'll label this as Z. Okay? Just trying to use different variables there so you can differentiate between all of them. So from there, I'm going to use again the cosine because this is the adjacent side. And here's your hypotenuse. And we're going to do the cosine of angle Z is equal to the adjacent over the hypotenuse. Okay? Now, I'm going to talk about this week while we do the trig functions, but in order to get Z by itself, you're going to multiply both sides by the inverse cosine. Cos negative 1. So Z will equal the inverse cosine of 9 divided by 9.9. Okay? Now this length of Z, this angle measurement of Z, I got to be 24.6 degrees. Okay? Now why that's important is because this. If we take that 24.6 degrees and put that in here, 24.6 degrees, add in the 90, okay, that's 114.6 degrees. What was the drainage requirements that we needed? Well, if you remember back at the very beginning, it has to be at least 117 degrees. So does it meet the drainage requirements? And the answer is no. So you will want to write out a sentence that says this would not meet the minimum drainage requirements of 117 degrees. Therefore, it is not advised to decrease the surface area of the roof by 10%. All right, now part C. The roofing shingles cost $27.75 for a bundle. Each bundle can cover approximately 35 square feet. Shingles must be purchased in full bundles. The builder has a budget of $325 for shingles. What is the greatest angle the builder can use to stay within budget, and explain or show your process? Enter your answer in your work or explanation provided. Okay, so anyways, here's what we're going to do. If the bundles cost $27.75, okay, and you have a total budget of $325, you want to divide those two out to figure out how many total bundles you can actually get. Now this equals 11.7 bundles. Obviously you can't purchase 70% of a bundle, and so you're going to have to purchase only 11 bundles. Okay, so that answers one part of the question. How many shingles can be purchased? The next part is this. If each bundle covers 35 square feet, you can go ahead and take the 11 bundles, multiply that by 35, and determine the square footage that you can cover with the number of bundles that you can purchase. So you can cover 385 square feet. Now, as I said before, you want to figure out the pitch of this roof with the number of bundles that you can actually purchase. So we know that this length is 18. I'm going to label this length again Y, and I'm going to redraw my roof so that we can see everything that's going on here. We know that this length is Y, we know that this length is Y, and that this length is 18. And so as a result, since we know that we can cover 385 square feet, okay? I'm going to take y plus y, which again is 2y, we've done this before, times 18, and set that equal to 385 square feet. If we go ahead and solve for y, we get a length of y to be 10.7 feet. Okay, now the reason why that's important is because this. If this is 10.7 feet, we now need to figure out what the measure of this angle is going to be. Okay, and so if you need to redraw that triangle separate of everything, 10.7 feet, 9 feet, figuring out, I'll say z. Again, we're going to use the cosine, adjacent, hypotenuse. The cosine of angle z is going to be 9 over 10.7, adjacent over hypotenuse. We're going to use the inverse cosine to get z by itself. And then from there, z is going to be approximately 32.7 degrees. Okay? And so what's the real question? What's the greatest angle the builder can use and stay within budget? Well, this is the greatest angle, the 32, and we're going to add in 0.7 plus the 90, so you have 122.7 degrees that you could use and stay within the purchased, the budget of $325. Okay? All right. On to the next question. Okay, now for number 9, we're told that angle Z is given in step 1. Describe the instructions for step 2 through 5 of the construction and your description in the space provided. You know, if I was to describe it, I would say something like this. Placing the compass point at point Z, I'm going to make an arc that's equidistant from that endpoint, from that vertex, and then label those points A and B. That's step 2. From point A, I'm going to make an arc that's greater than half the distance between A and B. For step 4, I'm going to make another arc that's the same distance as from A, and where they cross, I'm going to label it point C, and then I'm going to connect point Z to point C. And I don't think that they tell you to describe the construction. Yeah, so you're just describing the instructions for steps 2 through 5. You're not actually proving the statement, okay? Now, one thing I do want you to see, go back to that. This was the document right here. I don't know what page this is. That doesn't say. This is 6, okay? This is the answer document that I alluded to at the very beginning. If you go down to page number 6, right here in the part A, it tells you what they want or what they're looking for, okay? And so understand that there's probably a little leeway as you write that out. They're not looking for word, but I think it's important that you probably read over that and just kind of understand what they're looking for when they answer that. Because I know that you guys know what's happening. I mean, we've done that in class. You've done those constructions. It's been a little while, I understand. Okay, we didn't spend a lot of time on them. But again, this is where you could really pick up some small points there. For the next problem, it says this. It wants to explain the construction procedures. Marcel wants to explain why the construction produces an angle bisector. Marcella, okay. She makes a new step with line segments AC and BC added to the construction as shown. Okay, so we've got that right there. Now, using the figure, prove that ray ZC bisects angle AZB. Be sure to justify each statement of your proof. Well, here's what, I mean, I would write this out on my paper. I would say something like this. BZ and AZ are congruent because they're the arc is the same length passing through both line segments. Just something very simple right there. But it has to show that those two are congruent. I would also go ahead and show that BC and AC are congruent. Again, because these arcs are the same distance from the points B and A. Okay? And then I would go ahead and say something like this, that ZC is congruent to itself by the reflexive property. So ZC is congruent to ZC by the reflexive property. And then I would go ahead and say that angle BZC is congruent to angle AZC by CPCTC. Okay, that'll be a key one right there. Those corresponding parts, the congruent triangles are congruent. And then from there, as a result, I would say that ZC is the bisector of angle BZA by definition of angle bisector. Now, if you didn't catch all that, I really didn't want to have to write it all out, but going back to the answer document here on page 6, it kind of just steps it out right down here, what they are looking for. And I know that you guys know most of that information, okay? Actually, as I was citing that out, the one thing I didn't put down there is the side, side, side. So don't forget to prove the triangle's congruent before you use CPCTC. I should have done that, okay? All right, the next problem. All right, for number 10, we've got the billboard problem, and I'm going to let you read the first part of the paragraph. I know that I'm getting tired of reading things, and I'm sure that you're getting tired of hearing me read things. So the second paragraph, I'm going to read it out loud just to make sure that we understand everything that we're looking for here. So create an equation that can be used to determine x, discuss any assumptions that should be made concerning the equation, and use your equation to find the value of x. Show your work or explain your answer. So for the first part, actually for the second part, discuss any assumptions, I would definitely write down something like this. The post and the billboard are going to be perpendicular to the ground. So as I show this, this is going to be key right here, that those are going to be perpendicular to the ground. Therefore, the post and the billboard are going to be parallel to each other. Okay? Now, the reason why I'm setting this up, you can solve this one of two ways. You can use trig functions, or you can use similar triangles. And so if I show similar triangles, because that's what we've been working on recently, here's how I would do that. We know that this length right here is 4 feet. We know that the post is going to be 5 feet. And you can actually go ahead and do the Pythagorean theorem to figure out this length right here. 16 plus 25 is going to be 41, and the square root of that will give you the hypotenuse length of 41. So if I were to draw the two triangles separate of each other, we have the big triangle, which looks something like this. 41 square root of 41. This one is 5. Oh, I'm sorry, I was doing the big triangle. There we go. Big triangle is 26. This one's x. For the small triangle, here's what we have. We have 5, we have 4, and the square root of 41. And so if you set up a proportion to go ahead and solve for x, matching up the corresponding sides, you could do something like this. 4 is to x, as square root of 41 is to 26. And then you can go ahead and solve for it from there. Now, it doesn't say anything about how to answer the answer, and so as you cross multiply, we could say x times square root of 41 is equal to 104. And if you go ahead and divide through by the square root of 41 to get x by itself, you can go ahead and plug this into your calculator, and it will give you 16.2 feet. Okay? So that's one way you could go ahead and answer that problem, knowing that the triangles are similar, and the fact that the vertex angle here is congruent to the vertex angle there. Both have right angles, so by angle-angle similarity, we have similar triangles. Okay, so that's one way. Another way to go ahead and set this up, and I'm going to get rid of some of this stuff because I think it's a little busy over there. But if you like to use trig functions, here's what I would do. Erase. There we go. Okay. In order to figure out what x would be over here, we would have to figure out what y is going to be right here, because y is going to be the same in both of these problems, because the triangles are similar again. So as a result, I'm going to go ahead and say something like this. I can solve for y by doing the tangent. I think would be the best way to do it. This is the opposite side. This is the adjacent side. I would do the tangent, and the reason being is because the tangent, this side I know and this side I know to be true. This one, I could have made a mistake in doing that calculation. So as I set that up, the tangent of y is equal to the opposite over the adjacent. Okay? Now from there, we are learning, are in the process of learning. You will learn that in order to solve for an angle measurement using trig, you're always going to use what we call inverse trig, the tangent to the negative first power. And so that's what we have right there. That's going to be the value of y. Now, how do we solve for x up here? Well, this is your adjacent side, and this is your hypotenuse. So with the adjacent hypotenuse, you're going to use cosine, and I'm going to write that, I'll write that over here where I got more space. The cosine of the angle, which is y. Now y is this right here, so I'm going to go ahead and do this. The inverse tangent of 5/4. Set that equal to the adjacent over the hypotenuse. Okay? Now, we are just going to put this over 1 and cross multiply. So we get x is equal to, and then you're just going to multiply all this out. So it's going to be 26 times the cosine of the inverse tangent of 5/4. And again, you're going to get approximately 16.2 feet. Okay, when you work that out in your calculator. So either way is acceptable. I think the first way is probably a little bit easily understood, but after we get through the trig, you'll probably understand that way just as well, either way. All right, for number 11, line segment AB has endpoints at A at 416 and B at 24, lies in the coordinate plane. The segments will be dilated at a scale factor of 3/4. So that means that the next segment, or A prime B prime, will be a smaller length. It'll be 3/4 of the length of AB, and a center at the origin of A prime B. At the origin to create A prime B prime, what will the length of AB be? I'm going to go and get rid of this portion right here because it really has no bearing on the problem, and I'll show you why in just a second. If I go ahead and just sketch this out real quickly here. At 416, I'm going to guess 4 is here and 16 is up here. Okay. There's 416. Okay, at 24 over 20, I'll put that out in here somewhere. And up 4, about the same length there. Okay, here's your point 24. Okay. And if I go ahead and connect those two, there's my original length of that segment. The next length, or the new A prime B prime, has to be 3/4 of that. So what I'm going to do is I'm going to form a right triangle here. And the vertical length goes from 4 to 16. That's a difference of 12. The horizontal length goes from 4 to 20. That's a difference of 16. If you go ahead and set that into a right triangle and use your Pythagorean theorem, 16 squared plus 12 squared is equal to, let's say, c squared. 256 plus 144 gives you 400. And we square root 400 to get the length of c, which is the length of 20. Now that's good because I can then take 3/4 of 20 and get my answer there, which is going to be 15. And 15 is the answer that we want there for that problem. So that's a pretty simple problem. Just to make sure you understand, dilation, if it's 1, it's equal to, so you don't have to change the length. If it's greater than 1, it's going to be larger. If it's less than 1, it's going to be smaller than the figure. Okay? Okay, I really like this next problem. I think that all of you should be able to get it, especially after this next week when we work through trig. But here's what I want you to see. What we want to find out is what's the height of the tree in feet, the height in feet of the tree. So we want to know this whole length right here. Now, one of the things I'm going to talk about when it gets to trig functions is that it has to be within a right triangle. And what do we see? We see we've got two right triangles here. This one right here and this one down here. Okay? So I'm going to break it up. I'm going to solve for this length. I'll say this one's x and this one's y. And then I'm going to add those two together. So if we set this up, the first triangle looks like this. And this is the adjacent side. This is the opposite side, so I'm going to use the tangent function. And we're just going to cross multiply here. Okay, so that's the length of x. Now I'm not actually going to go ahead and solve that yet. I'm going to wait till the very end to do that. For y, here's what we have. I'm going to cross multiply there. All right, and again, I'm not going to actually go ahead and solve that because in the end, what I really want to know, and I don't want to lose any of my decimals in the process of doing this, is what's the total length going to be? So the height of the tree is going to be this. It's going to be 20 times the tangent of 42. And we're going to add in 20 times the tangent of 31. Okay? And again, this would be x plus y is your answer. And what you should end up with this, approximately 29.4 feet. Just break it apart, solve it individually, and then add them together. So that's a great problem right there that I think everybody should get correct. Okay. I'm going to skip the first two paragraphs there at the top where it kind of describes what's going on, and I'm going to go right down to the bottom. Here it says, Daniel wants to keep one chunk of the clay for later use. To keep the chunk from drying out, he wants to place a piece of plastic sheeting on the surface he exposed when he cut through the cube. Describe the newly exposed two-dimensional cross-section and find its area. Round your answer to the nearest whole square inch. Show your work. Okay, so what's happening here is they're pulling this through. We know that this is a cube, so this is 10 inches right here, and this is 10 inches right here. And so as a result, this is a 45, 45, 90 triangle, and so this is going to be 10 radical 2 inches right there. Now, what they're really asking for is what's the cross-section, and what I want you to see, I'm going to try to highlight the cross-section right here. The shape of the cross-section that we have to cover with plastic paper is this right here, okay? And so we know that the one length is going to be 10 radical 2, and that this length is going to be 10. And so if I was to redraw this, it's a rectangle there, so you want to make sure that you identify that the cross-section is equal to a rectangle. Okay, and we're going to go ahead and do this. 10 times 10 radical 2, which would be 100 radical 2, 100 radical 2, which is approximately 141 square inches. Okay, and that's how big the piece of plastic is going to have to be if we're going to cover just that portion of the exposed piece of clay. Okay, the next part says this. Part B, Daniel wants to reshape the other chunk of clay to make a set of clay spheres. He wants each sphere to have a diameter of 4 inches. Find the maximum number of spheres that Daniel can make from the chunk of clay. Show your work. Okay? Now, what I would make sure I do is I make sure I find out where the formula sheet is going to be for this test. Most likely in your paper pencil test, they're at the very beginning. If they're not, make sure you figure out where the formula sheet's at. The volume of a sphere is definitely something that they should give you at the beginning of that. So here's what we're looking at. We're going to take this portion, this top half, and we're going to try to shape it into spheres. So if you can't see what we're looking at something that looks like this. Okay, so we're going to take that portion, that triangular prism, and break it into spheres. Now, it says the diameter has to be 4 inches. And so the volume of a sphere formula is 4/3 pi radius cubed. Okay, we will talk about that a little bit later. I believe it's chapter 10. So if the diameter is equal to 4, the radius is going to have to equal 2. And so I'm going to go ahead and do this. 4/3 pi 2 cubed. Now remember, what's 2 cubed? It's 2 times 2 times 2. So that's 2 times 2 is 4, times 2 is 8. I could take 8 times 4, which would be 32. So what we're really looking at is 32 pi over 3, okay? And so that's the volume of one sphere. And let's see here. We want to know the maximum number of spheres that Daniel can make from this chunk of clay. So remember, this is 10, 10, and 10. Now the volume of a prism is base area times height, and the base sides are always parallel and congruent to each other. So this is actually the base that we're looking at. Okay, so volume of a prism is always base area times height. Okay, base area times height. So if I go ahead and take the area of this base right here, 10 times 10 divided by 2. The area of the base is a triangle. So 1/2 10 times 10. Okay, so that's the area of the base. And multiply that by the height of the prism. Now the height of the prism is the distance between both bases. So this is going to be our height of the prism, which is a length of 10 down here. And so I do that. 100 divided by 2 is 50. 50 times 10 is 500 cubic inches. Okay? Now, I'm going to go ahead and take this. I'm going to take the 500 cubic inches and divide it by, now you can actually reshape this. 3 goes into 32, 10 and 2/3 time. So if you would prefer to write out 10 and 2/3 pi, or actually go ahead and calculate that all out and get the decimal, you can. But I wouldn't lose any of the decimals there as I do that. So I would take that 500 and divide that by 10 and 2/3 pi, and that will give you approximately 14 spheres with a diameter of 10 that can be produced out of that, that size of a prism. Okay? All right. Let's see here. Next one, number 14, part A. Stuff that we've just been covering in class, factoring, or the quadratic equation. Let's look here. Got a parallelogram, stuff we covered a little while ago. AE is 16, okay. And here's what it says. Let BE be x squared minus 48. Okay, so x squared minus 48. Let DE equal 2x. Okay. What are the lengths of BE and DE, and justify your answer? Well, what I want you to remember about a parallelogram, remember that the diagonals bisect each other. Okay. So as a result, I know that x squared minus 48 must equal 2x. Well, we've actually got a quadratic here. We've been working on it the last couple of days. It doesn't look familiar quite yet, but remember they always have to be set equal to 0. So I'm going to subtract 2x from both sides and bring it over. So x squared minus 2x minus 48 is equal to 0. Okay? Now from there we can actually go ahead and solve for x. Now you can either use your quadratic formula, let's see here, negative b plus or minus radical b squared minus 4ac all over 2a. And I'll show you how to do that in a second. Or you can go ahead and factor it. Now the factoring on this one I think is easier than the quadratic formula. So if I do that, x, this would be minus 8 plus 6. And then from there, let's see here, it's going to be x minus 8 equals 0, or x plus 6 equals 0. So x is equal to negative 6, or x is equal to 8. Obviously, x has to be equal to 8 because when we plug it back in, we need a positive distance, not a negative distance there. So if I plug that back in, 2 times 8 is 16. 64 minus 48 gives you 16 as well. And so as a result, our answer has to be 8. To use the quadratic formula, remember you're going to take a is equal to 1, b will be equal to negative 2, and c will equal to negative 48. I'm just getting those from a, b, and c. Okay? I can plug that in over here. Negative b plus or minus radical b squared minus 4ac all over 2a. Okay, so this is 2 plus or minus radical. This is 4. 48 times 4, 160, and 32, 192. So plus 192 all over 2. 2 plus or minus radical 196, which is going to be 14. So this is going to be 2 plus or minus 14 over 2. 2 plus 14 is 16, divided by 2 is 8. 2 minus 14 is negative 12, divided by 2 is negative 6. Those are your possible answers, but we can only accept the negative 6. So the final answer, make sure you summarize that BE and DE are a length of 16, and you are good to go. Okay. Part B, what conclusion can be made regarding the specific classifications of the parallelogram justify your answer? Enter your answer in your justification. As far as the specific classifications, wow, they don't do any, not drawn a scale. That's pretty tough. As I'm looking at this, here are the things I want to make sure you see here. We already know that the diagonals bisect each other, okay, which is true. But we also need to understand this, that the diagonals are congruent to each other, okay? And here's one of those little, I mean, this could get you a lot of points on the PARCC test. If we know if the diagonals are congruent, what type of figure does it have to be? Well, it's got to be a rectangle, okay? And so maybe this is one also where you go back and you look at, what number is this? Is this 14? Yeah, 14, Part B on that answer document I showed you at the beginning. You may want to look back at that and say, okay, is there anything else that I really need there? But as far as what I'm seeing right here, just make sure that you identify that as a rectangle. And that's pretty much it. All right, next problem. Okay, we've got one of those coordinate proofs that we did quite a bit of. And so we want to figure out, let's see here. The figure shows a parallelogram PQRS on a coordinate plane, diagonal SQ and PR intersect at point T, and we need to figure out what the coordinates of Q are going to be, okay? So what I did here for this one, I went in and dropped a line down here, dropped a line down here. We did that in class earlier this year. I found this length, which comes from the X value here, so 2B. I found this length, which comes from the Y value here, which is 2C. I bring those same lengths over here because these triangles are both congruent to each other. And to figure out the distance from here all the way over to here, I'm going to go ahead and take 2A plus 2B. Okay? And the vertical distance is 2C. So 2A plus 2B, comma 2C would be the ordered pair for point Q. Okay? Now, for part B, it says, since it's a parallelogram, SQ and PR bisect each other. Okay, so let me go ahead and clear this off a little bit. I said 2A plus 2B, comma 2C. Okay, and they're telling us the diagonals bisect each other. So if you didn't get that on the previous problem, you know, there are some other problems that may lead you to answers on previous problems. So make sure that if you skip one, and then something else jogs your memory, go back to it and finish it up. And it says, use the coordinates to verify that SQ and PR bisect each other. Well, here's what I want you to know. If we can determine the midpoint of this segment to be point T, its ordered pair, whatever it is, and if we can determine the midpoint of SQ, whatever ordered pair it is, and they have the same midpoints, what do we know about the two segments? Well, they must cross at that point, thus proving that the diagonals bisect each other. So what I'm going to do, the midpoint formula should be something you've memorized already. But here's what it is. X sub 2 plus X sub 1, it's the average of the X's over 2, and Y sub 2 plus Y sub 1 over 2. Okay? So if we do that, I'll look at SQ first of all. If I add in SQ, or Q and point S, I'm going to have 2A plus 2B plus 0 over 2. And I'm going to do 2c plus 0 over 2. Okay? So if we go ahead and divide all this out, the 2's are going to cancel out here. So you're going to get a plus b, comma c. Okay? That's the midpoint of SQ. Okay? Now I'm going to do the same thing for PR. If I do that, I'm going to do 2a plus 2b over 2. And then I'm going to do 0 plus 2c over 2. Okay? And this is going to be a plus b, comma c. All right? So this is the midpoint of PR. Now, since both midpoints are the same, and I would write this out, since both midpoints are the same, therefore they intersect at that point, thus resulting in the diagonals bisecting each other. Okay? So, was talking with another teacher. Let's see here. We're trying to prove that the diagonals bisect each other. And I was talking with another teacher about this, what we could do. Something else you could do off the cuff if you didn't want to do the calculations there. If we know that this is a parallelogram, okay, I'm going to choose two of the triangles, these two triangles here. I know that the vertical angles are congruent. I could go ahead and state that. I know that the alternate two angles are congruent because the lines are parallel. I could go ahead and state that. And then I know also that the opposite sides of a parallelogram have to be the same measure. So therefore the triangles are congruent by angle, angle, side. As a result of that, by CP/CTC, I would know that those two parts were congruent, and I would know that these two parts are congruent, thus showing that the diagonals bisect each other. Okay, so again, maybe that's, I'm not sure if that one's on the answer document that is provided for us online, but if it is, it's probably a little more detailed than what I gave you right there, but I was trying to step you through that as quickly as possible because I've already talked for too long. All right, next one. Let's see here. Oh, we have a, yeah, I've already done that one. Okay, for this one, number 16 says here that we have a dilation and that we want to prove in the diagram to show the following theorem. Okay, being greater. Okay, so the factor, as long as it's greater than 0, is gonna imply that this new segment is going to have to be longer than AB. And so be sure to explain how you would use the diagram to prove the theorem and show justification for each statement in the proof. Enter your proof, your explanations, and your justifications in the space provided. All right, so what I would do, and they actually, here they show it. I don't think on mine, when I originally printed this off, at least it didn't show up on my paper. But I'm glad that they show that. What I want you to know, and we talked about this earlier, is that a dilation means that the segment has all the dimensions that are going to be increased by whatever the dilation is going to be. And so as a result, these lines are always parallel. Okay, that's going to be key for what we're going to be doing, because if you draw the two triangles separate of each other, okay, you're going to want to make sure that you state that angle C is congruent to angle C by the reflexive property. And then I'd try to prove the two triangles to be similar. I would go ahead and say that angle A is similar to, or is congruent, actually angle CAB is congruent to A prime, or angle CBA is congruent to B prime, because if lines are parallel then corresponding angles are congruent, thus proving the triangles to be proportional. Now what that means is this. You would then know that AC is to A prime C as, let's say, AB is to A prime B prime. Okay? And so let me see here. if we can figure out okay, we could go ahead and say whatever this ratio is going to be, AC, we could say that AC is going to be the equivalent of 1, okay? And then that A prime C is going to be the equivalent of K, whatever is going to be greater than 1 or less than 1, dependent upon if it's increased or decreased. But I could set that up because this is the original and this is where we're moving to. So I could say that K is the constant, the factor that's increasing the original by whatever factor it's going to be. And I could reintroduce the proportion that we have and then just cross multiply, and we have that equation that we needed to have, okay? Showing the influence that this segment had to this one on this segment to get that one, okay? And so, again, you can go ahead and take a look at the answer online, but how I would go about doing this is showing that we have similar triangles, and then after we have similar triangles, these proportions remain true, and if those proportions are true, then I can set up a ratio of 1 to K, 1 being the original, K being the scale factor of the original, and then cross multiply and I get that equation out. So, again, ask me questions if you have any questions on that. I know I didn't explain it quite the best right there. All right, and I think we are on to okay, so we got this farmer's supply. You got to store some grain that's being brought to your house, and so dump trucks deliver fertilizer in loads that are 4 feet tall, 6 feet wide, and 12 feet long. Farmer Supply wants to be able to store 2 dump truck loads of fertilizer. Oh, I said feed, not fertilizer. All right, so as a result, we need to figure out what the volume of that's going to be. And remember, there's 2 trucks that are being brought in there. So as a result, I'm going to go ahead and do 4 feet by 6 feet by 12 feet. Gives me a total volume of 288 cubic feet. Okay, that's the total volume. But there are 2 truckloads, so times 2 is going to give us 576 cubic feet. Okay. And what's important to note, and I don't know, yeah, it's set up above, the most we can have is a width of 8 feet. So the radius, the most it can be is going to be 4 feet. All right. And the height, the max height can be 14 feet. Okay. So as a result, the formulas, which they don't give here, but should be on your formula sheet, the formula for the volume of a cone, well, actually, let's start with the cylinder, is base area times height. Now the base is a circle, so as a result, it's going to be pi r squared times height. Okay? The volume of a cone is 1/3 of that, so 1/3 pi r squared times height. And so what I need you to understand is whatever volume we come up with here has to be greater than 576 cubic feet and must not have a radius greater than 8 feet. So I'm going to make the radius 4 feet just to maximize that length out as much as possible. Okay, and the height we'll talk about in a second. 1/3 pi, radius again 4 feet. Height we'll figure out must be greater than 576. Okay, and so because the height is 14, and we're taking this and we're dividing it by 3, I'm not going to put very much weight up in here. So I'll go ahead and put, let's say, 4 and 10. Let's see if that works out. Again, just throwing in numbers here. One thing you're going to recognize is at the very bottom of the answer sheet for this problem, it says anything that has a height of 14 feet or less and has a volume greater than 576 is an acceptable answer. So there isn't really one set answer for this one. So if we work this out, we have 16 here. 16 times 10 is 160. So 160 pi plus, let's see here, 16 times 4 is 64 divided by 3 is going to be 21 1/3, I believe. Okay, and then you want to take those two and add them together. Now, of course, my calculator isn't here, so I'm going to go get it and see if that works. Now, I went ahead and did that, the calculations. My calculator says that it's going to be 569.7 cubic feet. Well, that doesn't meet the requirement of having to be greater than 576. So I go back to the drawing board. Can I go backwards? Maybe not. I'll just go ahead and erase. Okay. And make this smaller here. Change the heights. Now, if I was way too large, all right, then I would have to decrease this, but I'm going to increase this. But because I was too small, I'm going to decrease this, make this 3 and 11. All right, so as I work this out, 16 times 11 is 176 pi, plus, let's see here, 16 times 3 is 48. 48 divided by 3 is 16, so you have 16 pi. And if you plug that into your calculator, let's see here, 76, 182, 192. Okay. If you plug it in your calculator, you're going to get 603.2 cubic feet, which does meet this. So as a result, if my radius is 4 and my height 1, make sure you designate which height that's going to be, is going to be 11, and your height 2 is going to be 3. Then we have enough space to go ahead and have them dump both truckloads within that that storage bin. Okay? All right. And we are here, finally at number 18. Okay, for the last one, we have points J, K, and L are distinct points where J, K is equal to KL. Which of these statements must be true and select all that apply? For the first one, that J, K, and L are coplanar, something I covered in the first chapter, but I don't know if you completely picked up on it. If not, that's fine. It's just a minor detail, is this. Whenever you have two lines that intersect each other, okay, no matter where they are, if I was to take those two lines and hold them up, consider them two sticks that are crossing each other, they would make a flat surface. I can rotate them any which way I want to, and they're still a flat surface. So as a result, if we have two segments that are intersecting, obviously they would have to be coplanar. All right, so if both segments, for example, if this was J, K, and L, obviously that would be the case of two segments intersecting each other, okay? Therefore, they would be coplanar. If they were all on one line and they were all collinear, J, K, and L, they're all on the same plane even though they're within an infinite number of planes. J, K, and L are collinear. Well, they could be, but they don't have to be all the time. So as a result, this one, not going to be true, okay? K is the midpoint of JL. Let's see here. If they were collinear, then this would have to be true. But do we know that they are collinear? And we do not. All we know is that they are equal in length. So as a result, this one also is not true. Do we know that JK is congruent to KL? Yes, we do. Because we know that JK equals KL. And the measure of JKL equals 90. We don't know that to be true. They could be collinear, which means the measurement would be 180. So, folks, I want to apologize. That was a lot of talking for me, a lot of listening for you. I hope you picked up something within the process of doing that. And I wish you guys the best. Like I said at the very beginning of this, you guys are the best. Go out and be the best, because I know you can. Good luck. If you need any other questions answered, please come to me. I'll do my best to help you out. Good night.